So we have already completed our first unit. Okay. So first unit means traction. Okay. So I am asking for some assignments like numerical problems about the traction. Okay. So how much you have completed or you have practiced in your home? Okay, you can submit it by coming. Today is Monday. You can submit it by coming Wednesday or Thursday. Okay. So how much you have completed the numericals? Okay, practicing the numerical to your homework copy. Only the numerical portions. Okay. So I will share you the link. Okay. So in this group, okay, for uploading your assignments. Okay. So that I can provide you, and I am planning to take one very simple test on tomorrow. Okay, so better if I can take the test on some extra class, so we can take some class on tomorrow. So if any you can provide me some time slot, extra time slot, okay, that may be in evening time also. I don't have any problem, and after 6 you can also give me some time slot. So if I can conduct one simple class test. Okay, so where you can practice, you can get a scope to practice for the mid-sem examination. Okay, as well as class test will be only based on some numerical problems. Okay, so maximum it will take 30-45 minutes. So I'm requesting you, so if you provide me some additional time slot. Okay, so by this coming Thursday. Okay, in between today's Monday, take some time for practice it. Okay, so you can give me some time slot any of the time on the date of Thursday, day of Thursday. Thursday I'm free. Okay, that's why I'm asking you. Every day having some class or lab something. Every day I have engaged. Okay, so Thursday total from morning to evening time I'm free. Every day I'm also free for evening time. I don't have any problem. Okay, you please let me know which time slot you are available, so we can conduct one class test like thing. Okay, so you'll get a scope how we are getting, I mean, how you can prepare for that mid semester, as well as one practice session will be there, and I will provide you the link for submission of your assignments only based on the numericals, how what kind of numericals you have practiced in your home. Okay, by this coming so by this coming Thursday. Okay, I hope all of you are getting my points. Okay, if you have any kind of discussion, you can ask. Okay, any doubts, any discussions, you can ask me. So we have we have already completed the traction. Okay, most of the theory and some mathematical analysis. Okay, for tractive effort. Okay, that has been discussed. Okay, and based on that formulas and the basic structures of that formulas, you can solve some very basic numerical problem. Okay, so I hope you are getting the idea how to solve it. So problem will very simple. Okay, some problem may be there like your based on some DC machines problem in Thereja book. Okay, you can also practice for it. Suppose traction motor. So simple problem will be there. Okay, nothing complicated one. Okay, simple problem, and the formulas are already discussed in my class. Now you are almost verge of completion. So simple problem from the machine will not create a, you will not face any kinds of difficulties on it, I think. Okay, if you're facing any difficulties, please let me know. I can also rediscuss some of the portions. Okay, if I get some more time, I can also solve some numericals. Basically, time span is less and content is very more. Okay, that's why I'm going for the next module. Okay, or next unit. Okay, that is utilizations. Okay, if we will get some time, so I am again discuss in my some previous some additional time slot after completions of your mid-sem exam. Okay, So here from the title you can understand that from the chapter title, so illuminations. Okay, that means it's related about our about our light. Okay, so light means what? So you know that electrical engineering means electrical engineering, that's lights are coming from anywhere. Okay, that can coming for any flashing. Okay, different aspects will be there for how to coming the lights, but in this chapter we are giving more only thrust on that light source, and that light source is basically you are getting from that electrical energy. Okay, so electrical energy is converted to the light energy. Okay, so that's why that one is known as illumination. So before starting of this chapter, we have to know about that what is our motivations for going through this chapter. Okay, so what is the importance of this chapter? That is very much important. Okay, so first you know that electrical engineering, it's an vast area. Okay, it's a vast area, so it having some separate segments. Okay, like specializations. Okay, so some of the segments, you know, like that machine drives. Okay, power electronics and machine drives. Okay, some of the most important segment is that power system engineering. Okay, then control system engineering, then measurement and instrumentations. Okay, so that is another specializations. And illuminations itself and specialization. Okay, itself a specializations basically. So different specializations are there. Okay, based on their application, lots of works are going on the illuminations. Okay, what kinds of works? You know that right now that I'm talking about when I had just started in this chapter, started subject. Okay, we're discussing about how we are going to reduce the losses. Okay, basically, when we are dealing with that electrical engineering, so main problem is that there are a lot of applications. Okay, and it's not like that only electrical applications. Electrical engineering is the one of the prime source or prime factor. Okay, and the applications can be in multidisciplinary range. Okay, so it can be there for sorry, it can be there for multidisciplinary applications. Means what? It can be that applications will be there for communications. Okay, and you can say like that some satellite applications anywhere. Okay, so broader area of applications are there. So main thing is that how do you reduce the losses? Okay, main losses is that electrical losses. Okay, power losses. Okay, so you know that initially when that light source are there, so when I think when you were in +2 level, so you've gone through one topic in your physics, that is modern physics. That was modern physics. Okay, based on that electron, proton, neutron. Okay, then other particles. Okay, other particles of our nucleus. Okay, some of them. Okay, so energy conversions. Okay, and where we are discussing about another portion was the semiconductor physics. Okay, before coming semiconductor physics. Okay, there was you know that plate based diode. Okay, diode, triode, pentode. Okay, defined. So we know their operations, flow of electrons. Some of the touch you are getting from CRT, cathode ray tube, in measurement. Okay, so main problem was those kinds of those generation devices. Okay, huge losses are there, power consumptions was more. Okay, and when you are talking about power system, you know that when we are designing every system for the base load. Okay, initial days is what we are doing. We are designing that every system for our base load. Okay, base load means you are installing one power plant nearer to your locality. Okay, when I was in morning school. Okay, that time one concept was there. Okay, so how much energy you have been consumed. Okay, your tariff range will be reduced. Okay, like that, based on your maximum demand. Okay, tariff was decided based on your maximum demand. How much maximum utilize you can do utilization. Okay, you can do utilize the power. Your tariff will be less. When a unit consumptions, more unit consumptions means less unit charge. In simple word. Okay, but then the grid concept was came. Okay, so then now you know that everything is dynamic. Okay, everything is dynamic. So okay, so based on your how much power demand you are giving, based on that your pricing will be there. Okay, more power demand from your end means more pricing. Okay, so same thing, the reductions of losses. So now at those day what kinds of for the light and light sources of the light, everything has been changed from their generation to generation. So initial days is there is a sodium vapor lamps, mercury vapor lamps, okay, halogen. Okay, when you know that in festive season, okay, so we are conducting our different mela like that thing. So okay, so halogen lights was there. Okay, mercury tubes. Okay, so there is a mercury tube. Then tungsten lamp. Okay, tungsten filament lamp. Okay, 1000 watt. Okay, so can you imagine? So 1000 watts, so huge. Okay, huge losses are there. Then heating. Main thing is that in our, you know that when I was in hostel, there's a strictly prohibited to turn on the heater. Okay, turn on the heater means coil heater. Okay, so it was uncontrolled and huge power will be there. It's more than 200 watt. Okay, if you turn on the heater for 1 hour, so I think you are able to understand how much unit consumption will be there. Okay, so 1 kilowatt hour for 1 unit. Okay, so 2 kilowatt hour means for 1 hour, 2 kilowatt you are consuming. Okay, so more than 2 units. So if it is continuous the time range, so huge power consumption will be there. Per unit cost is around 5 rupees. Okay, for and every day 10 watt 10 units if you consume, so every day 50 rupees. So monthly bill is almost more than 1500 rupees. Okay, so that's why it's strictly prohibited in the hostel. Okay, now the concept has totally changed. Now induction heatings are there. Okay, so everything will be coming gradually. For the light energy, what we are doing that time, that tungsten filament lamp, then mercury vapor lamp. So generation is changing. Okay, after that, what happened? You know that fluorescent lamp. Okay, fluorescent lamp also be there after tungsten filament lamp. Then reduction of the losses. What you are doing? You are replacing tungsten filament with the carbon filament lamp. Okay, so why carbon filament lamp? You know that negative resistivity. Okay, so more that means increasing of temperature reduces resistivity. So time dependent. So loss may be less, but it's quite costly. Okay, tungsten filament lamp you can get in the market 10 rupees. Same feature, same thing you can if you design for carbon filament lamp, it may cost for 2000 rupees. Okay, so these kinds of changes are there. Okay, so after that, what happened? That fluorescent lamp is there. Okay, fluorescent tube. Now it's that in our home. Okay, we are normally using that 40 watt fluorescent tube. Then we are using some lesser range of fluorescent tube that may cost for 20 watt. Okay. After that, what happened? We are using CFL. Okay. So CFL was there. There in case of CFL, what happened? We are using ballast circuit. In fluorescent lamp, what was there in the choke? Okay, choke coil is there that may responsible for development high voltage. Okay, so that can responsible for the choke coil is responsible for generating the high voltage. Okay, that high voltage may cause for breakdown the medium. Okay, so in between that two electrode in the fluorescent lamp. Okay, so air medium is there. Okay, so due to that high voltage, it can be ionized. Okay, ionized and electron flows are there. Okay, after flowing of the electron, so that it will be glowing. Okay, but choke can consume huge power. Okay, so what you are doing now, you can go for that reducing the size of the choke. Okay, how do you reduce the size of the choke? So you are using ballast circuit. Now it was used that ballast circuit. Okay, so it's a you know that LC circuit. Okay, high frequency operations. More frequency may cause for what? Reductions of their sizes. Okay, reduction of their sizes. Okay, so what you can do? Reduction of sizes means same work will be there, but size will be less. So you can save some of the energy. After that, another that revolution has came. That was your LED lamp. Okay, so you know that I can recall as like 5 to 6 years back. Okay, not more than that. 5 to 6 years, not more than that. Okay, so three scientists got that Nobel. Okay, so there are some based on they did their work on LED. Okay, so in LED, what happened? That color variations. Okay, at that time it's not. That time nobody don't know how to get the different color variations. Three scientists was there, I think so. They're from Japan, I think so. I am not able to recall all those things, but some of the portions I am recalling. Okay, so so they just invent that process. Okay, and very old age. They are more than 80 to 85 years old, I think so. Their age. Okay, so they got that Nobel Prize. So it was a breakthrough. Okay, after that we are getting same intensity of that light. Okay, so in technical points of view, it is called lux. Okay, lux, lumen. Okay, so same intensity of those things. Okay, of those light we are getting by using only, you know, that 9 watt LED. Okay, so we are using in our home. Okay, in standard. Okay, so government having also some scheme. Okay, you know, you can see one discriminations, the price rating of those LED lamp. Okay, when it was first launched in India, when where government was giving some subsidy. Okay, so like that, those are having electric vehicles. Okay, they are getting subsidy when they are filing for the tax. Okay, till now they're getting subsidy. There are a lot of company they are doing startup. Okay, for installations of vehicle charging stations. Okay, basically I am to discussing some of the portion that is not all the track of our study, but still I think this is important. Basically, in your end of the day, you all people the torch bearer of our nation. So some of you your friends are very much interested about the startup. Okay, we are discussing about the startup. So government also giving different fundings about the startup. So now sustainable transportations is just like that COVID. Okay, so 2 years back, not more than that, I was attended one course. It was in NPTI. Okay, I went there for attending the course. So I met a lot of person. Okay, they are from not a single person from the academics. Okay, I am the only person who went there to attend the session. Not session, it is a course. Okay, I attend the courses. Okay, so most of them from that startup companies. Okay, as well as industry person. Okay, so I see saw that a lot of person they are getting some startup for developing different software interface. We know that we are discussing about the charging stations of vehicles. Okay, but it's not like that only electrical features. No, it's totally wrong. There is a huge applications of software. Okay, and if you going to design, if you will to install some electric vehicle charging stations, you will get some subsidy from the government. You are having lot of fund. Okay, you are getting lot of fund from the government, as well as you are getting your own revenue. Okay, it's like that MNC. Suppose you are designing then you can give that scheme to other person, and you can also design some of the software. How just like you can understand, just like Uber, Ola. Okay, we can see that where is our Ola, where is our Uber, means where it is situated now. Different apps also be there. Okay, in Indian market. So you can see what the charging stations, how much their occupancy. Okay, different very interesting things are there. Okay, those are really interested, they can think about it. Okay, again I am go back to my topic. So that there is a LED lamp. Okay, so there is a discrimination, price discrimination. Suppose 9 watt you are getting only 100 rupees, but if it is more than that, it's taking cost for 250 rupees. Okay, basically government gives you the subsidy. Okay, that's why you are getting. And most important factor, that is your reflector. Okay, in light energy, how much you are getting, how much lux you are getting or lumen you are getting from your system. Okay, from your light. Okay, so source of light. So main thing is the reflector. The designing of the reflector, it's another important features. Okay, so these are all are the very important and very interesting idea. But that we are in our subject, what we are going to discuss, that I am giving you some idea on it. So I hope you all people can understand what is illuminations. Okay, why it is important, that is most important thing. Okay, why it is important. Okay, and how we can achieve all those things, that's why there are different features on it. So in this chapter, main important factor is that different definitions. Okay, we're having a lot of definitions from Lux to MNCP, MNSP. Okay, and different definitions, as well as some numericals problems. Suppose that I am talking about some specialization, specialized subjects. Okay, we are giving the brief on that throughout the specialization. Suppose some people can go design for stadium electrifications. Okay, stadium lighting. Okay, how much number of light you need to get. Okay, what type of light you are going to install. Then that corridor lighting. Okay, different lighting is that hospital lighting. Okay, so now that smart lightings are there. So in television you can get some different advertisement. Okay, from mobile phone, I saw one advertisement that one mobile phone you are changing the lighting arrangement of your home. Okay, so it's a smart app lighting. So I'm talking about the apps. Okay, so application oriented. So all of the multidisciplinary work. Okay, so you have to design the app, and based on that app you are giving the instruction to your concern sensor. Okay, so they are fetching your so they are giving the signal, there is a receptor. Okay, from getting the signal directly they are accessing. Okay, so that IoT concept was there. Okay, like that thing. Okay, now all those things have already there in the market. Okay, so very fast this fields is growing on. Okay, so it's very quite interesting. So we are discussing about some of the important important definitions. Okay, after discussing the definition, we'll discussing about different types of numerical problems. Okay, based on our definitions and their applications. Then we will discuss about different applications, suppose stadium lighting. Okay, different lighting methodology, and what are the different types of lamp. Okay, these kinds of thing we are going to discuss. Okay, for the meet set, how much we are able to complete. Okay, that up to that portions exam will be there. So not total chapter I will complete, some of the portions I will complete, and pending portions will be covered after the meet set. Okay, so I'm asking you to find out a slot. Okay, find out a slot for giving the class test. Okay, I'm expecting that you can give the test on maybe test on before Thursday. Okay, any of the slot you can provide me. Okay, evening time, any of day, and otherwise Thursday anytime. Okay, I'm free. So we are discussing about that illumination. So okay, so what are the most highlighted portions? Okay, in introductions we are just talking about that most highlighted portion. So producing the artificial lights. Okay, whatever light we are talking about here, that all are the electrical light. Due to electricity you are getting the lights. Okay, not the practical one. So first one I told that one. So main source of that electrical energy. Okay, so artificial light. Okay, rising in a solid body or the vapor or the incandescent, and that's filament lamp by applying heat on it. Okay, So how do you get that light like that? You know that giving heat on a body of that instrument. So directly the light is generating from there. Okay. So it is found that the body is gradually heated. Okay. Body is gradually heated above the room temperature. Okay. And beings radiate the energy. Okay. You know that infrared. So hotspot. Okay. So hotspot camera is there, you know, like that when in cricket, okay, we are using that hotspot, okay, tracking. So now hotspot is not so much used. I didn't see that hotspot. Now they are showing that how much that acoustic concept they are using. Okay, sensor, acoustic sensor. They're touching with your back. So there is a, but in a few years back there is a hotspot. But hotspot camera is very much familiar or very much familiar in our power system engineering. Suppose you are using that insulator, okay. So how do you know that the health of the insulator? Okay, so you are just below of your tower, and how do you know the health of your insulator, tower insulator? It's not possible to touch there and understand. No, it's not possible. Okay, so that's why what you are doing, you are using that hotspot camera to see the heat distributions of your individual insulator. Okay, we are using string insulators for tower. Okay, so pin type insulator is not normally used for 130 kV, so that is up to 33 kV. Okay, pin type insulator. Okay, pin type. Okay, so you can understand that how much heat distributions are there. Okay, from that camera, hotspot camera. Okay, so there is a infrared radiation. So normally they are catching that infrared. Okay, heating is uneven. So low wavelength heating is there. That's your infrared. Okay, is being radiate energy in the surrounding medium. Okay, from the surrounding medium. So from the electromagnetic waves of various wavelength. Okay, so based on the heating pattern, so different lightings are there. Okay. So the nature of the radiant energy, okay, the nature of this radiant energy is depends on the temperature of the hot body. Okay, so that I am telling you. So how much is you are getting to it? So temperature of the hot body. Thus, when the temperature is low, radiate energy in when thus the temperature is low, the radiated energy is in the form of heat wave only when the certain temperature is reached. Okay, so it can radiate up to temperature heat. After that, what happened? That heat energy is converted to the light. Okay, then light waves are also radiate out from that addition heat wave of the body become the luminous. Okay, now you know that body become the luminous. Okay. Further, increasing temperature. Okay, now what you are doing, again increasing the temperature, produce an increase of that amount of both kind of radiations. Okay, kind of radiation, but the color, okay, but the color of light and visible radiations changes from bring red to orange. Bring red to orange. Okay, so that idea is plus 2 level idea. I hope you can recall it. So very basic thing again I have mentioned here, so for your understanding. And yellow, okay, so first red to orange to yellow, and then finally it becomes the white. Okay, you know that white color is combinations of all the lights. Okay, so this thing are very common. Okay, as temperature is increased, okay, as temperature is increased, the wavelength of the visible radiations goes on becoming shorter. Okay, shorter. It should be noted that heat waves are identical to light waves except they are longer wavelength and hence produce no impressions on the retina. Okay, so it's about our eyes. Okay, so obviously the point of view light emissions, heat energy represents so much wastage of energy. It is found that maximum radiant efficiency, okay, maximum radiant efficiency would occur around 6200 when even the value of the maximum efficiency would be 20% only. Okay, since the temperature is so far highest, So it been obtained in practice, it is obvious that the actual efficiency of the artificial source of light depends upon the temperature incandescence. Okay, so it's low. So if total depends on the temperature, what happened? Definitely it goes to what happened? So definitely efficiency will be very less. Okay, and it is also changing with the time. Okay, so radiant energy, the energy radiant out from that light, total energy radiant by the hot body. So from the hot body it will be radiant. Okay, so light is your one thing feature. The sound energy, if you transmit from one point to another point, so medium is required. For light, no medium is required. Okay, light, heat. Okay, so that light is no medium is required. Okay, so now very important, some of the important uh, sorry some of the important definitions. What are the definitions for illumination? First one is that you know that solid angle, that is very important. Okay, so what is solid angle? Okay, solid angle, it is known as that omega. That angle is area per radius square. Okay, okay, steady then, stay radian. Okay, so the unit of the solid angle is stay radian. Okay, so consider an area A which is part of the sphere. Okay, so you are assuming that is a point source of light. So now how it will be get it? So you can draw a circle, or in 3D, you can draw a sphere with the taking of r radius. Okay, with the taking of r radius, you can assume a sphere. Okay, so what is your solid angle? Okay, if it is point sources, means source of light, you can consider at the origin. So it will be the area. Okay, area per unit radius square of that sphere. Okay, how much area? Angle, that angle will be there A. Okay, so A whole divided by your radius square. Okay, so consider an area which is part of sphere of radius r, which is part of a sphere of radius r. Let us find the solid angle omega. Okay, solid angle omega is your area. Okay, omega subtended by an area at the center C, okay, of the sphere. For this purpose, let the point C is joined to every point of the edge of the area A. Okay, so that you can understand. So C point is there here. You can see that this is your A. Okay, this is your A area. Okay, so it is your C. Okay, now we can consider total thing is that a circle. It's like that a circle. Its radius is r, and that A is your area. Okay, and that is your omega. Okay, this is your omega. So what is the value of omega? Omega equal to A whole divided by radius square. Okay, the unit of solid angle steradian SR. Okay, so if the above equations A equal to R square, then omega equal to 1. So 1 steradian means 1 steradian means your area, okay, area and radius square both will be coincide. Okay, hence the steradian is defined as the angle subtended. Okay, angle subtended by area. Okay, at the center of a sphere by the part of a surface being an angle equal to radius square. Okay. So how much area? So that area will be defined like that way, that radius. Okay, that radius, two radius is there covered with that area A. Okay. So now important definitions. Okay, what are the important definitions? First one is that candela. So what is your candela? It is a unit of luminous intensity of a source. So what is candela? Unit of luminous intensity. You know that flux intensity? Okay. So in candela is your luminous intensity of a source. Okay. It is defined as 1/6 of the luminous intensity per centimeter square of a black body radiation, black body radiator at the temperature of solidifications of platinum with 2045 degree Kelvin. Okay, the standard one. A source of 1 candela CD emits 1 lumen per steradian. 1 lumen per steradian. Okay, and the total flux emitted, okay, total flux emitted by, it is rounded in 4 pi into 1 equals to 4 pi lumen. Okay, so what is luminous flux? It is the light energy. What is luminous flux? It is the light energy radiated, okay, light energy radiated out per second from the body in the form of luminous light wave. Okay, since it is the rate of flow of energy, okay, the short, okay, the short of power unit, okay, the unit of luminous flux is lumen, that is Lm. Okay, it is defined flux content, okay, it is in flux content per unit solid angle of a source of 1 candela or standard candle. Okay, so flux content per unit solid angle. So flux content means, you know that solid angle, if 1 equal to, when solid angle 1, A equal to R square. Okay, both can be coincide. Okay. So flux content per unit solid angle of a source of 1 candela or standard candle. Approximately the relations between the lumen and the electric unit of the power. That means what is given as 1 lumen equal to how much power? What? 0.0016 watt. Okay, very less. Okay, very less. And lumen hour means, if it is the quantity of light delivered in 1 hour. Okay, so it is the quantity of light delivered for the 1 hour by the flux of 1 lumen. Okay, so it is known as the lumen hour. Okay, it's similar to like that what? It's similar to like that watt hour for energy. Okay, lumen hour is the unit of also energy, light energy. Okay, this is unit of watt hour is, you can say like that, it is unit of electrical energy. So lumen hour is the unit of light energy. Okay, so I can understand, I think you can, all of you can understand what are the definitions. Okay, definitely other definitions also be there. Okay, so first another definitions. Okay, what is the definition? That is luminous intensity of the candle power. Okay, luminous intensity, that is known as I, and candle power. Okay, of a point source. First point is that of a point source in any particular direction. So any directions you can take is given by the luminous flux, is given by the luminous flux radiated out per unit solid angle in that directions. Okay, so luminous flux radiated out per unit solid angle. Okay, per unit solid angle, that means solid, omega equal to 1, again a square equal to a equal to r square. Okay, in that directions, how much flux is radiated at that area. Okay, in other word, it is solid angle flux density of the source is specified directions. Okay, it is solid angle flux density. Okay, solid angle flux density, how much is there? Okay, of a source in the specified directions. Okay, so these are the very basic one. So how can you mathematically write all those points? Luminous intensity, the d phi. Okay, d phi, if you are considering luminous intensity, okay, luminous flux retained out by the source within a solid angle. Okay, solid angle is there, changes of solid angle d omega. Okay, steradian in any particular directions. So you are getting that how much how much how much luminous flux is radiated. Okay, with that solid angle, that is known as change of solid angle, known as dW, steradian, in the particular directions. Okay, some fixed particular directions, then I equal to d phi by d phi d omega. Okay, rate of change of flux. Okay, with the variation solid angle. Okay, omega is solid angle. Okay, so you will get that value. Okay, that is known as luminous intensity. If flux is measured in lumens, okay, so flux is measured in which parameter? Lumens. You please remember all those things. Okay, lumens. And solid angle, and the solid angle is steradian, then its unit is lumen per steradian. Okay. So lumen per steradian. So you know that I equal to so d phi is your flux by change of what is omega solid angle. Okay. So what is your intensity? That is coming intensity of ILM per steradian. Okay, from here you are getting that then is unit is lumen per steradian, lumen per SR. Okay, that also known as Candela. Okay, that also known as Candela. Okay, the total for 1 radian it is there. 1 radian, how much value is it? Okay, omega I. Okay, so if you are go for if you are go for enter the enter the sphere, okay, so it is 4 pi. Okay, angle is your 4 pi, so omega value will be how much? Omega equal to 4 pi. Okay, directly you will get the 4 pi lumen. Okay, your phi value. Generally, the luminous intensity or the candle power of a source is different in different directions. Okay, so all the things are different. Okay, based on how your lighting energy is spread out. Okay, is there any cover? So definitely the cover portions, that value will be less. Okay, generally the luminous intensity or the candle power of a source different in different directions. Okay, so changes are there. The average candle power of a source is the average value. Okay, the average candle power of the source is the average value of its candle power in all directions. Okay, so all the directions will provide you that power. Okay, obviously it is given by the total flux in lumen emitted in all directions in all panels. Okay, the divided by 4 pi. Thus, average candle power is also known as mean spherical candle power, MSCP, means spherical candle power. So, how much lumens, okay, or flux are coming over the sphere, okay, divided by 4 pi. So, that is called mean spherical candle power. Okay, so how much candle powers are coming throughout your area? Okay, so what is the throughout area? That is 4 pi of a sphere. So this is known as MSCP. So MSCP is important for the exam. Okay, so today I have discussed up to this much. Okay, so in my next class and tomorrow we can continue about the next portions, means next definitions. So I hope you people are solving the numerical problems. I will share you the link as soon as possible and submit me. Okay, I'll share the time period. After that, it will not appear. Okay. I hope all of you getting my idea. So any uh, doubt from your end?